Okay, good afternoon, good morning to my fellow students and chemistry colleagues out there. Um, this video is for the benefit of those that want to sit for NECO 2022 examination. So I want you to pay attention carefully. If you know what you are expected to do, you don't have any cause to panic. Everything will just be so easy. Okay, from the specification we have for the exam, NECO has given us a specimen, and the A specimen is triazonitrate 5 acid. That is our AN. And this is to be prepared by diluting 9.50 cmp in 1 dmp, that is 9.50 cmp in 1,000 centimeter cube. And also, the B is sodium triazocarbonate 4, okay, which is to be prepared by dissolving 4.2 grams of sodium triazocarbonate 4 in 1 dmp, that is 1,000 cmp. Alright, but before you go into this, as a good chemist or a good scientist, you should first of all do your hypothesis, that is your theoretical work, to know, to guess, to know what you should expect. Then before you conduct the experiment. So that's the reason why I'm giving out this video. Okay, so before we conduct the experiment, before we perform the titration, let's even know the concentration of these samples that are given, so that we can guess or do our hypothesis or theoretically know what our average titer is going to be. Okay, now for this, for HNO3, the bottle is always the stop is always in an amber bottle, and if you check the amber bottle, you will see this specification. The specific gravity is 1.42, okay, and the percentage purity is about, the one we have here is 70%. So we want to know the molar concentration in that stock bottle, so that we can know our concentration in this measured volume. Okay, so how do we know the molar concentration of this stock solution? We can know it by doing the simple calculation. So that will give us the concentration, that is the C, the stock of the stock. Let me put it like this: the stock is going to give us the specific gravity times the percentage purity over the molar mass times 10. So let's see what it's going to give us. So this should give us 1.42 times 70, and of course the molar mass, let me write it here: molar mass of HNO3. Molar mass of HNO3 is going to give me 1 plus 14 plus 3 times 16, and that should give you, this is a 15 plus 48, am I right? Which is what? 63 gram per mole. Okay, so I'm going to have 63 here, then times 10. So when you do your calculation, you multiply this and divide this and multiply by 10, you're going to get 15.8, which is the mole in the DMP. That's the concentration of this stock solution. So let us now get the concentration in this diluted form. So we're going to use our dilution formula, that is C1V1 is equals to C2V2, where our C1 is the original concentration of the acid, which is 15.8, times the volume that we are going to take out of it, which is 9.50, is equals to our final concentration, which is what we are looking for, times we are going to make it up to 1,000 centimeter cube. So therefore our C2 is going to give us 15.8 times 9.50 over 1,000, and that will give us about 13.20 centimeter cube. Okay, so this is sorry, that will give us about 0.15 mole per dm cube. So this is the concentration of the acid that we are going to work with. This is the concentration of the acid that we are going to work with, 0.15 mole per dm cube. Now, let's now look at the concentration of the base. Sorry, let me take this off. The concentration of the base now. So this is our Ca. Now the concentration of the base that we are going to work with, which is our Cb, is going to be the concentration in gram per dm cube over the molar mass of the base. So the concentration is given in gram per dm cube is given at 4.2 over the molar mass of sodium carbonate, that is Na2CO3, is going to give us 2 times 23, which is the mass of sodium, plus 12, which is the mass of carbon, plus 3 times 16, which is the mass of 3 atoms of oxygen, and that should give us 106 gram per mole. So we fix this here, 106 gram per mole, and our Cb, the concentration of the base, is going to give us 0.0396 gram per 0.0396 mole per dm cube. So 0.0396 mole per dm cube. So therefore, theoretically, we have our Ca to be 0.15 mole per dm cube. Our Cb is going to be 0.0396 mole per dm cube, and our Vd is always the volume. It's always the volume of the pipettes, which is 25.0 cm cube. Then the number of moles of the acid and base, we get that from the equation. So the titration is going to be between HNO3 plus Na2CO3 will give us NaNO3 plus, remember, acid and base. We always the carbonates will release carbon dioxide, CO2, then water. So we have to balance this one. This aqueous. So we have to balance this. We have 2 sodium atoms here, so let's fix 2 here, and we have two hydrogen here, so let's fix 2. So the number of moles of the acid is what? 2 ratio 1. So our Na, let me fix this here, our Na is going to be 2 and our Nb will be 1. So let's now see what we are to expect. Let's see what we are going to, let's see what our average, expected average titer is going to be. And that is our VA. So using the titration formula, CAVA over CBVB equals NA over NB. So substituting all this, remember our CA is what? 0.15 times the VA is what we are looking for over our CB is 0.0396 times 25, which is the volume of the pipette, the volume of the base, equals Na, that's the number of moles of the acid is 2 ratio 1 for the base. So when we cross multiply, our VA will be 0.0396 times 25 times 2 over what? 0.15 times 1. And that will give you about 13.20 centimeter cube. So what we are expecting here is 13.20 centimeter cube at most. So if you exceed this, then something is wrong somewhere. So you can get within the range of, let's say, 12 point something up to 13.2. So this is the theoretical one. Now let's go to the experiment proper and see if our hypothesis is going to be true. And let's do that right away. And then you come. So all these have been washed and rinsed. My burette, I'm going to stand it. My burette. Okay. And there you go. Then I have my conical flask all washed and rinsed. I have my conical flask. Okay. So I'm going to measure out the acid into the burette up to the 0 mark. So okay, it's over the 0 mark, so I'll adjust it right here. Ensure that the burette is standing horizontally, and make sure you read to and also avoid error due to parallax when you are taking your reading. So it's on the 0 mark now. Hope you are capturing it. Right. So it's on the 0 mark. So the next thing, I'm going to pipette out my base. I've transferred the base here. Okay, I measured it earlier and I've transferred the base here. So I'm going to measure this 25 cm cube of the pipette. So I'll do that up to this mark. Alright, so this is my 25 cm cube of the base. So you don't need to blow the pipette to take away all the solution. Just tap it down, down, and you have your 25 cm cube of the base. So for this reaction, I'm going to make use of phenolphthalein. So this is a titration between, I'm going to make use of phenolphthalein solution. And you can see phenolphthalein is pink color in a basic medium. So the titration is between a strong acid and a weak a base. So we can also use methyl orange. So you start your titration and ensure you shake and shake until you get a color change. So you can see it's almost there, almost there. All right. So we have a color change now, and move the camera. Let's take the meeting together. Can you focus the camera? So you can see this is starting. This is 13, the ticker mark 13, 13.1 is between 13.1 and 13.2. So I will say is a 13.15. 13.15. So if you do what you are expected to do rightly, then your average title value will be 13 point something, 12.8, at most 13.2. But for this experiment now, I got 13.15, okay, which is quite accurate. Then in my next video, I will be taking some likely questions under these experiments. I hope I've been able to help the little I can here. Thank you.